Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students in advanced functions. It's a video on trigonometry, and in particular in this video we'll be doing some trig fundamentals involving radians. So in order to do some fundamental trig questions, we need to have a set of tools available to us, meaning the things that you should know in advance based on what you learned in grade 10, 11, or have learned so far this year. All of these are things that you learned in grade 11, except for, of course, you'll see that all my angle references are in radians, no longer in degrees. So, of course, the first thing is that you should know what the trig ratios are. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So when you hear me say SOHCAHTOA, I'm reminding myself as to which ratio is relevant, opposite hypotenuse, adjacent hypotenuse, or opposite adjacent. And in addition, I put below a reminder about the reciprocal ratios. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tan. So all that means is that for cosecant, I do hypotenuse over opposite. And for secant, I do hypotenuse over adjacent. For cotan, I do adjacent over opposite. Or what I actually do is if I'm finding cotan, I just find tan, and then I flip it upside down, and so on. You also, of course, need to know the cast rule. And the cast rule is really just a simplified way of saying, remember that there are different quadrants in which the principal angle may lie, and that there are some of the sine ratios, cosine and tangent. Some of your trig ratios are positive or negative depending on where the terminal arm of the rotation is. So when I say cast rule, I'll be bringing up, I'm reminding ourselves about in different quadrants there are different polarity for the different trig values. And again, you'll see that in a couple questions. You also have to, of course, know the special angle relationships because this is not a video about how to use your calculator, it's a video about more fundamental questions. So the special angles are pi over 4, which has trig ratios as represented by this triangle, and pi over 3 and pi over 6, whose trig ratios can be found using this triangle. And also there are these super special angles, which are 0 degrees, pi over 2, pi, 3 pi over 2, and 2 pi. So in other words, the super special angles are the ones that aren't in quadrants at all. They're the angles that lie exactly on the axis, and again, 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. And so my preference in my own brain for how I remember these is with these little diagrams. So this sort of represents my toolkit, the stuff that's easily accessible in my brain when I do these trig questions. So let's do some questions and see how to use them. So here's a good question. It says, find the exact value of sine 4 pi over 3. So my process is always to start by thinking about two things. One, what quadrant would this particular angle be? So if I were to rotate by 4 pi over 3, what quadrant would I end up with? Because if I know what quadrant I'm in, then I would know which trig ratios are positive and which ones are negative. And then the second question is that I need to find the related acute angle for 4 pi over 3, because the related acute angle has the same trig ratios as the given angle, except for the polarity is different, and the polarity comes from knowing the quadrant. So let's just do this question. So first of all, I'm going to draw a little sketch, and I'm just using a straight line tool, but on an actual quiz or test, I would just kind of draw that freehand. I wouldn't pull out a ruler. It's not, a graph, it's just a sketch. So where is 4 pi over 3? So we know that in radian terms, that the primary angles are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And those represent the boundaries for the quadrants. Now, because in this question, we're dealing with an over 3 situation, then I'm actually going to rewrite all of these as something over 3. In other words, instead of thinking about this as pi, I'm going to call it 3 pi over 3. It's still pi, but now I can think in terms of the actual angle that I have, which is 4 pi over 3, and now I can see where 3 pi over 3, and that gives me a much better idea as to where this angle is. Now, I can already kind of visualize where it is, but I'll just keep going. Because I've now taken 1 pi, which is what used to be right here, and I've cut it into 3 pieces, I'm going to show all the pieces. So here's pi over 3. Here's 2 pi over 3. Here's 3 pi over 3, which we've already labeled. It used to be called pi. Here's 4 pi over 3. Here's 5 pi over 3. And of course, that would make this 6 pi over 3 or 2 pi. So now I can see all of the terminal arms that represent pi over 3 and all of its related angles. So here is 4 pi over 3, and that's the angle we're talking about. So using the cast rule, what do I know about this angle? Well, I know that it's in the tangent quadrant, which means that only tan and cotan are positive, which means I know that when I get an answer to this, because it's sine and not tan, I know my answer will be negative. So I already know that sine 4 pi over 3 is a negative value. I just don't know what it is yet. What else do I know already from my diagram? Well, now I want to find the related acute angle. And the related acute angle is always the angle formed between the terminal arm of the principal angle, and that's the angle that started at 0 and rotated. So I want the related acute angle, which is formed between the terminal arm and the x-axis. And because of the way I've set it up, by dividing my rotation into pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3, it's very easy to see what this angle would be. I went from 3 pi over 3 to 4 pi over 3. So the related acute angle is pi over 3. So if I can figure out what sine pi over 3 is, then I know that sine 4 pi over 3 has the same value, but a different polarity. So I'm going to now use my special triangles. So let me grab my special triangle, which I've drawn in advance. And again, typically, you've heard me say this in class a lot. The first thing I knew that I used to do when I would write a trig test like this is I would draw these at the top of the test so they were available. So here's pi over 3. So I'm ignoring pi over 6. I don't want to look at that right now. I'm looking at pi over 3. Sine, thinking about SOHCAHTOA, is opposite over hypotenuse. So sine is the opposite side over the hypotenuse. So now I know that sine pi over 3 is root 3 over 2. So what does that mean? Well, I'm basically done because I already know that sine 4 pi over 3 has the same value as sine pi over 3. And I know that I'm in a quadrant where my actual answer should be negative. So the answer to the question, what is sine 4 pi over 3? The answer is negative root 3 over 2. And there's my answer. Now, I certainly, am making a mess of this page, but I'm dealing with technology that is a lot more complicated than a pencil and a piece of paper. So let's see that again with a different question. So here's another question, same idea. We want to find the trig ratio cosine, and we want to find cosine for 11 pi over 4. So again, the first thing I want to do is find what quadrant I'm in, and then the second thing I want to do is I want to find the related acute angle, and that's the symbol we use, beta. So here is, boop, boop, I didn't use a ruler that time. Here is the 4-quadrant system, and I've divided pi into 4 pieces. So let's go and draw some lines that represent cutting pi into 4 pieces. So remember, pi is over here. So I'll cut it into 1, 2, 3, 4 pieces, and I'm going to call this 4 pi over 4 instead of pi. So here's pi over 4, and 2 pi over 4, and 3 pi over 4, and so on. So I'm going to keep dividing it, and I want to figure out where is 11 pi over 4. So I'm going to do this by counting. So here's 0 pi over 4, 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, can grab another color, 8, 9, 10. Here is 11 pi over 4. So that's where the terminal arm of this rotation is. Now the rotation is a full circle and a little bit more, but again, trigonometry in a rotational sense means that we see a lot of repeated angles. So I know that cosine of 11 pi over 4 is equal to the cosine of 3 pi over 4 because they're the same terminal arm. But for now, what I really wanted to know is that I am in quadrant number 2. And in quadrant number 2, only sign is positive. So I know that my answer to this will be negative something. Again, that's because I'm in quadrant 2, and in quadrant 2, only sign is positive. The question was about cosine, so my answer should be negative. Now I have to think about the related acute angle. So again, what I like about the diagram is that the angle formed between the terminal arm, which is this one, and the x-axis is this little angle here. And by looking at what I've done, 3 pi over 4, 4 pi over 4, so this must be pi over 4. So if I can figure out what cosine of pi over 4 is, then I can use that answer to finish the question. So again, looking back at my special triangles, there's a special triangle for pi over 4, there's pi over 4. Cosine is adjacent over hypotenuse. So the cosine of pi over 4 is 1 over root 2. So that's my answer, except for it's negative because of where the terminal arm is. So cosine 11 pi over 4 is negative 1 over root 2. Now, that's a fine answer. It's correct, but it's not communicated properly. We want to rationalize that denominator because, hey, that's what we do. So we're not allowed to have root 2 in the denominator. So I'm going to multiply by the number 1, but it's this version of the number 1. And that's going to give me negative root 2 over root 4, or 2. So that's the answer that I'm looking for cosine 11 pi over 4. So every question like this involves the quadrant and the related acute angle. Let's try another one. This time we want the tan of negative pi over 6. So again, we're going to start by finding the quadrant. So don't forget, negative pi over 6 means I rotated the wrong way. And I rotated the wrong way by pi over 6. So let's think about what would happen. If I was to rotate all the way from there half a circle, I would have rotated by negative pi. But since this question is pi over 6, let's actually write negative 6 pi over 6, and then we'll cut this system into 6. So there I have 1, so 0, 1, 2, 3, 4, 5, 6 pieces. So each of these little wedges is a pi over 6 measurement. And so 1 pi over 6 puts me right here. Rotating backwards by pi over 6 puts me here. So now I know that I am in quadrant 4, and according to the cast rule, only cosine is positive in this quadrant. And my question's about tan. So I already know that my answer will be negative. Negative something. So now I need to think about the related acute angle. And again, you can see, here's my terminal arm, here's the x-axis, so what is this angle? Well, because we started this question by cutting into pieces that were pi over 6, I know that that little angle is pi over 6. So all I have to do is figure out what is tan of pi over 6, make it negative because of the quadrant, and I have my answer. So let's look at the special triangle. Boom. So here's pi over 6. So I'm ignoring this. So for tan, I want opposite over adjacent. So katoa is opposite over adjacent. So the tan of pi over 6 would be 1 over root 3. So my answer is negative 1 over root 3. Oops. However, we need to rationalize that denominator because we always need to rationalize the denominator. So I'm going to multiply this expression by the number 1, but this version of the number 1. And that'll give us negative root 3 for the numerator. The denominator would be root 9, also known as 3. So that's my answer. Let's try another one, a little bit different this time. Let's see what happens. So this time I want to find the value of cosine negative 5 pi. And again, I'm always thinking about quadrants and related acute angle. So we're rotating backwards. So here's 0, here's negative pi. So again, I'm going backwards, right? And then so this would be negative 2 pi, and this would be negative 3 pi, and this would be negative 4 pi. So negative 5 pi is right here. The terminal arm is on the x-axis, and that makes it a super special angle. So in order to find that, I don't worry about the quadrant system and I don't worry about related acute angles because it's super special. And I should have known that because any super special angle always has a denominator of 1 or a denominator of 2. That makes super special angles. So let's think about how I like to think of super special angles. I like to visualize them. This is cosine. So let me visualize cosine. There's cosine. So hopefully you drew this graph enough in grade 11 that you're super comfortable with it. And the way that I like to refer to it is that this is where I start a rotation, and then this is the next major piece, and then this is the next major piece, and that's where I am, right? I'm at the 0, 1, 2. I'm at this 0, 1, 2. I'm at the second major important interruption. And I can see from this graph that the value would be -1. So I know that the cosine of -5 pi is equal to -1. And there's lots of different ways I know that students remember this. Not everyone likes the graph, but however it is that you're comfortable memorizing those super special angles, make sure you have them memorized. So let's try another one. So again, here you can see for sure this is going to be a super special angle because it's over 2. So let's think about where that would end up on this graph. So if I start here at 0, this is pi over 2, pi, and here's 3 pi over 2. So let's highlight that. Ooh, let's use yellow. So, oh, yellow's not too bright. Here we go. This is where I am. That's where 3 pi over 2 is. Should have known that anyway, right? You should for sure know these 4 angles without any sort of mnemonic device. This is where I am. And what is the tan value? So how do I do tan? Well, again, you may have memorized something that I haven't. This is what I know. My brain likes pictures, so I use pictures. So my brain wants to show me the sine curve and the tan curve. Sorry, the sine curve and the cosine curve. 3 pi over 2, where is that? 0, pi over 2, pi. Here's 3 pi over 2, which is at -1 for sine. And here's 0, pi over 2, pi. Here's 3 pi over 2, which is at 0. And we know that tan is equal to sine over cosine. So it's -1 over 0. Oh, I can't divide by 0. And that means that there actually is no answer to tan 3 pi over 2. It's actually what we call undefined. And if you were to try to type that into your calculator in radian mode, your calculator would say math error because, hey, you can't do it. It's dividing by 0, and that's not allowed. Slightly different question, but it still requires us to find the trig ratio. So let's do this question. So clear your brain for a second because this one's a little different. It says the point, -8, 18, lies on the terminal arm of a rotation by theta. So we have to use our axes and rotate by theta, and we need to make sure that our rotation, our terminal arm lands at this point. And then what we're supposed to do is to determine all 6 trig ratios of the principal angle. So let's figure out where this point is. If I go -8 and up 18, I'm about here. And again, the diagram's just to help. I'm not making it perfect, obviously. So there is the terminal arm. So here is what the principal angle sort of looks like. Not to scale, but I'm in the right quadrant, so everything's fine. So that is the rotation by theta. So I need to find sine theta, cosine theta, and tan theta. Those are the 3 primary trig ratios. And since it wanted all 6, I need to find cosecant theta, secant theta. Oh, look what I did. Let me fix that. Cosecant theta, secant theta, and cotan theta. So that means I need to know where is this triangle and what are the side lengths. So we always draw the triangle with reference to the x-axis. So there's the triangle. Here's the related acute angle that allows us to use all of the trig ratios for this triangle will also apply to the principal angle. The only difference between and let me label it here, the only difference between the trig values of the related acute angle and the trig values of the principal angle are going to be the polarity, because this terminal arm is in the second quadrant where only sine is positive. So when I find the values of opposite, hypotenuse, and adjacent and use them to set up my trig ratios, I have to remember that cosine is going to be negative, and therefore secant will be negative, tan will be negative, and cotan's negative, and that's because the terminal arm is in the quadrant where only sine is positive. So now let's talk about what the side lengths are. So I'm just going to redraw this triangle, even though I'm not trying to draw it to scale. So here's that related acute angle. Now remember, what we know is that this point is at negative 8, 18. And that's important because now I can take these values and say, oh, if this is a triangle, then this is a side length of 8, and this is a side length of 18, and now I can find the length of the hypotenuse side using the Pythagorean theorem. So let's see what we get. C squared equals 64 plus, oh, calculator. So we're just using the Pythagorean theorem. And again, please don't turn things into decimals. We want exact answers as much as possible. So 64 plus 324. So C squared equals 388. Ooh. So C equals root 388. So before I go any further, I want to see if that reduces at all. So very quickly, just a reminder about how to reduce. I want to find the largest perfect square that evenly divides into the number 388. And I know some of you have, ooh, look, I skipped one. I know some of you have calculators that do this for you automatically. Isn't that nice? I don't. So I'm going to do it my way. So I really quickly found out that that 388 can be written as 4 times 97. And I'm pretty comfortable with that because 97, I don't think that's divisible by very much. So this is equivalent to 2 root 97. And so that's the value I want to use, not this one, okay? So let's go back up here. Now I know that here's my triangle. This side was 8, this side was 18, and this side is 2 root 97. So now I have, for this angle, the hypotenuse length, the opposite length, and the adjacent length. And all I have to do is write my trig ratios. So sine, which I know is positive, is opposite over hypotenuse. And so cosecant is just flip it upside down. Now a couple things. I am going to want to go back and reduce 18 over 2 and rationalize the denominator, but let's finish the trig part of this question first. Cosine is adjacent over hypotenuse, and therefore cosecant is just flip it upside down. I already have a negative sign there. I tried to draw it. And tan is opposite over adjacent, 18 over 8, and therefore cotangent is 8 over 18. And you'll notice that I already put my negative signs in, so I'm not going to repeat that. So those are my values, but some of them need to be worked on for sure because I've got some fractions that can be reduced. I've got some rationalizing to do. So let me just take all this stuff to a nice clean page. Hey, it worked. And let's clean this up a little bit. So in sine, I have a few things to do. So 18 over 2 is 9. So I have 9 over root 97. And we want to get rid of root 97 in the denominator. So we're going to rationalize multiplying by 1. So in the numerator, 9 root 97 over 97. So that's the value for sine that I would want my teacher to see and mark. So do we have any problems with cosecant? A little bit. Cosecant, so if we go back to my raw value, root 97 is in the numerator, that's good, but 2 over 18 can be reduced. So it's just root 97 over 9, and that's a nice looking value. So let's look at cosine. So again, in cosine, just like in sine, we have some reducing to do, 8 over 2, and we have a denominator that requires rationalization. So cos theta, so first of all, it was negative 8 over 2, right? So it's negative 4 over root 97, and then rationalizing the denominator like this. So in the numerator, I have 4 root 97, nothing to be done, but at the bottom is just 97. And so that's the value of cos theta that I want my teacher to see. And then let's see if secant theta needs to be played with. So the only thing wrong here in secant theta is that I have 2 over 8, which can be reduced. So secant theta is negative root 97 over 4. And tan, how's tan doing? So I don't have any radicals to worry about, but I do have negative 18 over 8 and negative 8 over 18, both of which can be reduced. So tan theta is negative 4 over 9, and cotan theta is negative 9 over 4. So those are the 6 trig ratios, exact values in proper form for the principal angle on this terminal arm. And I think that's it for this video. All of those questions, remember, were about you finding the trig ratio of certain angles. So in the next video, I'm going to talk about how to find the angle if you know the trig ratio. Thanks for paying attention. Do your homework.